Okay, Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Wassalatu wassalamu ala ashrafil mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Allahumma la sahla illa ma ja'altahu sahla wa anta taj'al hazna idza sita sahla. Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning everyone.
Walaikum
Good morning,
assalam.
Doctor.
Good morning, Doctor.
Right. Okay. Okay. Okay, let's continue from the previous one, which is the still in the rigid body to the equilibrium. Okay, so I already explained about the example 1 and also example 2. Yeah, example 2 here. Okay, so before we start, is there any question from you regarding the example 1 and example 2?
No, Doctor.
Okay, if no, let's proceed to the next slide. Okay, so the previous one, we have learned about the FBD, free body diagram. Yes, of course, we learn to draw the FBD, we learn to determine the reaction, we learn to identify the number of reaction, and how many numbers. We learn about on how to know the DOF, degree of freedom. Okay, degree of freedom. Okay, so based on the degree of freedom, you can determine how many reaction involved in the system. Okay, once you have the FBD, let's say you have this FBD. Okay, and maybe the question giving you the known value. Okay, known value, let's say a B equal to 100 Newton. Okay, mg equal to maybe 20 Newton, for example. And then a question asking you to find AY and AX, for example. Okay, once you have the FBD, then you can solve the AY and AX based on this one. Okay, based on this equilibrium system. So you have learned about the equilibrium system, which is summation of forces or summation of moment must be equal to 0, in which we follow the Newton first law. Okay, Newton first law. Okay, so before you apply the Newton first law, you have to make sure that you draw the FBD for every single solution. Okay, you have to draw FBD, okay, to make sure that you can determine the unknown value later on. Okay, every single system from the question, from the new real life condition, you must draw FBD. Okay, and even in a test or final exam, if no FBD in your answer sheet, you will get 0 mark for the FBD. So make sure that you draw FBD. The drawing should be including yeah, of course, the geometry. Okay, which is the shape shape of geometry. Okay, the forces, and also number 3 is the dimension. Okay, the forces either internal or external. Okay, so make sure that in your FBD you include all those 3 elements. Okay, must be including geometry, forces, and also dimension. Okay, so once you have the FBD, then you can get the unknown value. Okay, the unknown value from the body. Okay, so to get the unknown value, you must use the economic system. Okay, the first one that I just said just now is about the force. Okay, summation of forces must be equal to 0. and summation of moment must be equal to 0. Okay, so for moment can be taken from any point, even from points outside the body. Okay, so let's say you have this simple rigid body. You have 3 different points there. Okay, so A, B, and C. Okay, you can take any moment from any point. You can calculate moment from any point. Let's say you are calculating moment about point E. Okay, so you will get some equation later on. Okay, and then if you don't want to have the moment at point A, you can take a point B or C. Okay, so you will go through later on. Okay, and yes, for the forces, normally in 2D we'll use two component, which is X and Y component. Okay, for the 3D later on, you will use 3 components, X, Y, Z. So more complex than 2D. Okay, for moment, there are many points. So maybe point E, point B, point C. Okay, so moment can be taken twice or yeah, maybe more than 2 lah. Okay, if the system have more than 3 points, then you can calculate or use all points to get the equation. Okay, so the example 3. Okay, we will use the Newton first law. Okay, we will draw the FBD in this example. So this is the simple example, which is you have to determine the reaction at E and D of the rigid body shown in the diagram. So what you have to do is, what is the idea that you want to find? What is the final output that you want to get is the reaction at E and D. Okay, E and D. Okay, so my first question, what is the first step to solve this problem, to solve this example? Anyone?
Free body diagram and determine the reaction, that effect on it.
Okay, thank you. Husam, is it?
Yes, doctor.
Husam. Okay, so yes, correct. The first thing, of course, we have to draw FBD. Draw FBD for the desired body. Okay, so how to draw? So you have to based on the question lah. Okay, based on the question, but this is a simple one. We do have only one single body, which is AFD. Okay, AFD body. Okay, so you have to draw AFD like this. Okay, with the roller there. Okay, draw it. Exclude the thing that you don't want. For example, this one, the wall, and this floor, for example. Exclude this one. So you have this FBD. Okay, the second step is you have to determine the reaction. So for example, we are taking A first. How many reactions there? How many reactions at A?
2.
Okay, 2, yes, 2. Which direction? Can you state to me? Can you say to me?
X and Y.
Yes, correct. So we do have, we do have this one, AY, and also AX. Okay. How about point D? How many reactions there? Point D, Point D. How many direction? Okay, one. Wong King Tong said one. Yes, correct. So in which direction?
Moment.
No, not moment. In which direction actually? For D. Which direction? Come on, guys. D, at point D. In which direction? Wang Jiayi. Are you with me?
Yes.
Which direction for D? Anyone? Which direction for D? D, 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 D. Ding, 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 ding. Coming out from the wall. Coming out from the wall. From the wall. Oh, okay. Upward toward the rollers. Upwards. Okay. All right. Okay. Points toward. Okay. So basically the answer is almost correct. But to imagine that we have to draw lah. Okay. So basically when you have this roller, oops, alamak, dapat jawapan pula. Okay, basically you have this roller. Okay. So there is one touching surface there between the roller and also the floor lah, for example. Okay. So this roller can go this way, okay, but cannot go this way. Okay, this way can. The moment also can. Okay. The thing that cannot be moved, cannot go, is the reaction. So the reaction must be must be pointing to the roller lah. Okay, so it should be perpendicular like this. Gitu. So it must be perpendicular to the surface. Okay, perpendicular like this. This one should be perpendicular. So this is the reaction. Let's say I put it D lah. D. Okay, so then you have to put all the forces that involve. In this case, only one force. So you put I think there lah. Okay, so far so good. Any question? Any question? Any question? No. Okay. Is this completed or not? Is this ABD completed or not?
There's 50 Newton force.
Yes. There is another one. Yeah. 50 Newton. Thank you. Okay. Is this FBD completed or not?
Yes.
No. The answer no yet. What is the thing that we miss here? Yes, kat chat ni, alamak, janganlah suruh saya baca chat. Kadang-kadang saya tak perasan. You have to say lah, So yes, of course, the dimension. You please do remember to put the dimension. Yeah. This dimension, this one, and this one. 3.8. 0.5, 0.3, 0.3, and also 1. Okay. Finish. Finish. Okay. This is your FBD. So normally, if you complete this FBD, okay, if you complete this FBD, normally I will give 3 until 5 marks in final exam. Okay, it depends on the complexity. More complex, more mark. More simple, less mark. Okay, so make sure that you draw the FBD and include all the shape, geometry, the forces, and also the dimension. Okay, right. So what is next? What is next? What is next? Someone? Oops.
Equilibrium.
Yes. Equilibrium. Okay, let me do something here. I want to erase this thing. Huh. 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 Macam mana ini? Okay, so this is your FBD. This is your FBD. Okay. Okay. So this is your FBD. So what's next? Because the question asking you to find the E, Y, and EX, which is the reaction at E, and also reaction at D, which is D. Okay, so how to find it? How to find?
Do the equilibrium for X and Y.
Okay. X and Y. Yeah. So how about D? D. Can we do the X and Y component? Can we resolve the D into X and Y component?
Yes, sine cosine the degree 30.
Yeah, great, great. Okay, so let's say we resolve the D component, the D force into two components. Okay, into two components. Okay, let's say I put it here lah. Okay. So the previous example, sorry, the previous slide showed that the degree is 30 degree. Okay, 30 degree. Let me check again. Okay, it's located at there. Okay, should be like this. This is the line. Okay, and the 30 degree should be here. Okay, 30 degree should be here. So for the dx and dy, it's based on the d as well. So you have to resolve. Oops. You have to resolve like this, and then you will get d is equal to dx equal to d sine 30, and dy is equal to d cos 30. Okay, am I right?
Yes, doctor.
Okay, what's next? After resolving the d, what is the next step?
All components for X and Y equal 0.
Yes, correct. But you have to bear in mind, okay, you have to bear in mind, there are three. At the moment after you resolve the d, you have four actually. You have four unknowns, and you have four unknowns. Okay, the first unknown is ay, the second unknown is ax, the third unknown is dy, and the last unknown is dx. Okay, you have 4 unknowns. Basically, in static, in this particular lecture, actually, if we have 4 unknowns, meaning that we have to develop 4 equation. Okay, the equation is actually based on the number of unknowns. If the unknowns only 2, then you will have 2 different equation. If 3 unknowns, then 3 equation. If 4 unknowns, then you have to develop 4 unknowns. Okay, to develop 4 unknown is not realistic. Okay, it is difficult actually. It is difficult. Okay, it is difficult. Do you get?
Yes.
Yeah. Okay. So let's say the first thing that you want to do is you want to have this equilibrium system for x component lah, for example. Okay, you determine the x component there. Okay, we do have let's say I put it right is positive. Okay, and then the x, let's say start with the ax first, and then minus 80, and then plus dx, sorry, d sine 30 equal to 0. Okay, and then for the fy equal to 0, I assume that output is positive. Okay, and then we determine the component ay minus 50. Okay, and then plus dy is equal to d cos 30 equal to 0. Okay, all right. So from here, from these 2 equation, actually you cannot solve it. Okay, you cannot solve it. You cannot get the ax, ay, and d. Am I right?
Yes.
So what is actually another way to develop an equation? Another way to develop the equation? Anyone? 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 Eh, Siti Nol Balkis, huh? Do you have the answer? What is the other method to develop another equation? Siti Nol Balkis, are you with me? Okay. Ada jawapan tak?
Sure lah, Doctor.
Not sure. Okay, anyone else? What is the other method? What is the other possible method or any equation?
Doctor,
Yes.
use moment.
Yes, correct. Siapa yang cakap ni Ikmal
Yes, Doctor.
Okay. Yes, correct. We use moment. Okay, we use moment. Okay, so okay. Moment, yes, correct answer. So which point you want to take the moment? Which point that you want to calculate the moment?
Point A.
Okay, why point A?
No idea.
Main hentam je lah. Ni tembak lah ni.
Maybe no apa ya? No theta, Doctor. No apa ya? Sudut.
No, angle. No, bukan.
Ah.
No. The answer is correct, but why? We should take a moment about point A. Yes, the answer is correct, but why we should take a moment about A point? Why not D? Why not F? Why not a 50 Newton there? Why A? -5. Not only Ikmal. Okay. I can see some answer from the chat box. Okay. So the answer is correct from Wong Kin Tong. Okay, to eliminate the largest number of unknowns. Okay, the largest number of unknowns. Okay, so in this case, the point that having a lot of unknowns is at A. Okay, because at D the unknown is only dy and dy and dx. But again, you have to bear in mind dy is equal to d, which is only d here. Ds is only d here, so it can be considered same value. Okay, but at A you have to different unknowns there, ay and ax, in which ay is not equal to ax. So meaning that we have two unknowns at A. At D, only one unknown. Okay, so that's why the reason why we take moment at about point A is actually because we want to eliminate the highest number of unknown. Okay, it is same goes to other problem later on. If you do exercise, if you do some test question, you have to choose the point that have the point that have more number of unknowns compared to other point. Okay, so that's why we choose a moment about point E. Okay, and must be equal to 0. Okay, let's say clockwise is positive. Okay, so the moment. So how to calculate the moment? We do have a 1, 2, 3, 4. Yes, 4. 4 forces that we have to consider in this calculation. Okay, we start with 50 first. So the force is 50 Newton, and the dimension is 1. Okay, all right. And please check the direction, is it positive or negative? So in this case, for 50 Newton, it's follow the assumption clockwise here, then it should be positive lah. Okay, for the second force, which is 80 Newton, it should be negative. Okay, it should be negative because it is oppose the assumption, which is the positive is clockwise. The 80 Newton is oppose the assumption. Okay, so it should be negative 80, and the dimension is 0.3. Okay, and then the second one, the third one is dx lah. Okay, dx, and then dx should be negative as well. I put it here, dx, and the dimension is from D to the from the line of action of the dx to the point A. Okay, which is 0.8. Okay, and then the last one is dy. Okay, dy should be negative as well. Okay, should be negative as well. And the dimension, the d, the perpendicular d is from the line of action of dy to the point A, which is 1.3 minus 0.8, which is 0.5 lah. And must be equal to 0. Okay, do you get? Do you get the moment? Every single forces, for every single forces. Do you get it? This one. Any questions so far? Yes, correct. Thank you to siapa yang cakap ni? Yeah, Akila Shasha. Also Wong King Tong. Okay, great. So it means that you understand the AT should be positive. Saja nak test. I want to test you. So yes, correct. It should be positive. Okay. Any questions so far before I proceed? Any question? Any question? No. Any question? Actually, there is some mistake also. I intentionally do in this equation to check your understanding. Okay. The first one that you mentioned is the sign of 80 Newton. There is another one actually. Which one?
DX, Doctor. Correct. Yes, sir.
Yes, correct. So it should be D only. Okay, it should be D only. No need to put dx dy. Okay, put D only. Okay, I intentionally do this because I want to check your understanding. Okay, you should pick D. Okay, because dy is equal to D. Dy. Shasha Akila. Akila Shasha dy.
Doctor, we should
Space,
include
space.
cosine, Doctor.
Yeah. This one, my mistake. Should be okay lah. Should be okay. It's my mistake. Sorry. So this one should be okay. Dx and dy. Okay. Sorry, this is my mistake. Dy. Okay. Dx dy. Let me check again. Dx 0.8. Terbalik Kan, betul tak? Betul lah. Okay. Okay, so this is the correct one. Dx is 0.8, which is 0.3 plus 0.5. Dy is 0.5. Okay, correct. Yes.
Doctor, can we just make like we have 3 unknown and 3 equation? I mean, like we know that dy equal to d cos 13. So why not we put dy d cos 13, so cos 13 multiply with 0.5.
Again, I cannot get you.
Can the doctor say we have 4 unknown? But
Yeah, for
why would we change to 3 unknown? Ax, ay, and d. We know that
Yeah.
dy equal to d cos 13. So why not we replace dy at the moment equal to 0 with d cos 13. So cos 13 multiply with 0.5.
Cos 13 multiply with 0.5 dy. You replace dy, is it?
Yes, dy.
Okay, can also can. It is mathematics. As long as the method is correct, then you can do it. Okay, siapa tadi? Ikmal
Yes, doctor.
Okay. Can, no problem. Okay. Okay, next. Let me continue next. You have to substitute this one into this. Okay, this one into this. Okay, you will get the final answer of D later on. Okay, so let's do it together. You will get this minus, oops, lemak. Minus dx d sine 30 minus d cos 30, okay, equal to 0. So you will get d here. Can you help me to calculate the d value? Calculate the d value for me. Siapa ni? Dipa. And siapa dapat ni? Sekejap Oh, Wan Kim Tong also got the answer. Okay, yes, the answer is 88.8 Newton. So this is your D. So you have the D value, and then let me do quickly. So you substitute into this equation and this equation, okay, you will get AX and AY, okay. AX, how much? AY, how much? So AX from the answer is 35.6. Please check the answer. And AY is a 26.9 Newton. Please check the answer. Is it correct? Is it same? This one should be negative. AY should be negative. AX is positive. Yeah, Wong Kin Tong. AY is negative. Okay. All right. So if you have this, you already get D. Oops. D, which is 88.8. Okay. Actually, you can simplify the reaction at A. Okay, reaction at A. Since you have two components, you can make it one single force, which is the resultant here. I do it long like this. Okay, you can get A straightforward. Okay, using the Pythagoras theorem. And then you will get A equal to 44.6 Newton. And then of course you can get the angle there. Okay, since the AY is negative, it's pointing downwards. This one 35.6. Okay, this is your A. And then this is your theta. Okay, so you will get theta equal to 37.1. Okay, 37.1. Okay, let's do quickly the last one. Okay, the last one I intentionally explain very detailed about the example. Okay, You can check the solution later on. Okay, let's do this exercise together. Let's do this exercise together. Okay, we have only 10 minutes left. Okay, let's do this exercise. Okay, the question asking to find the reaction at D and the tension in the cable of the rigid body shown in the diagram. Okay, so what is the first thing that you have to do is the FBD. So how to draw the FBD for this system? Which body you want to select? Please, quickly. Which body you want to select?
ABCD, Doctor.
Yes, ABCD. Air batu campur durian. ABCD. So you have to draw ABCD. Okay. Macam mana nak buat ni? Sekejap Okay, let me do something. Keep it. Let me do this one. Okay. Okay. So you have to draw the desired body, which is A, B, C, D. Okay. Wait now. Give me 1 second. 1 second. Okay. Draw it together with me. You can draw in on your sheet of paper. Okay. So draw A, B, C, D. Just put the point there, A, B, C, and D. Okay. C, B, A. Okay. So you have the shape, you have the geometry. So what's next? What's next? Come on. Someone. What's next? Okay. What's next? What is the next action? Someone? Okay, reaction. All reaction, there is only one reaction, which is at D. So how many component at D? How many component at D? Reaction at D, how many? Okay, the answer is correct. 3. Okay, 3. Okay, because it is embedded, it is placed inside the wall. Okay, it is placed inside the wall, meaning that we have X, Y, A, Y, and D as D, Y, and also moment. Okay, so we have this one. Yeah. Okay, draw together. You can draw anywhere that you like in your paper. D, Y, D, X, and moment D. Okay, moment D. And then don't forget to put the other forces. Okay, like this one. 150 Newton. Okay. So what's next? How about the A and C? How to make the component, make the force? Someone? 6 minutes left. Tension AC. Okay, tension, yes. Okay, tension. So it is coming from A. Okay, let's say I put it T only. Okay, because there is only T. And C also T lah, because it is same cable. It is same cable. Okay, it is same cable because this is the pulley system. Yeah, it is same cable. So we have this tension and this tension T. Yeah, and of course, but but in different direction lah. Different direction. It's not parallel actually. It is not parallel, but the magnitude is same. Direction is different. Magnitude of t is same. Okay, so what's next? The FBD is not completed yet. What's next? Yes, dimension. So put all dimension there. Okay. From here to here, from B to C, from C to D. Okay. 0.08, 0.08, and also 0.2. Okay. This still not completed yet. What is the other element, parameter, or things that we have to put in the FBD to make easier for the calculation later? The last one, the information that you should put in the FBD, what is that? XY component of tension, no need to put it at the moment because we want to draw the first FBD first. So the component can be done during the analysis, during the calculation. Okay, the answer is angle. Yeah. Li Jiawing, angle. This angle actually. This angle. Okay, this angle. I put it theta 1, for example. And the second angle is theta 2. Okay. All right. So this is mathematics. So how to determine theta 1 and theta 2? This is not static. This is mathematics. How to determine theta 1 and theta 2 from this figure? Anyone? How to determine theta? Yes, theorem Pythagoras. Theorem. Yes, theorem Pythagoras. So which triangle, or let's say we are choosing the theta 1 first, which triangle that we have to choose? We need to choose. We must choose. We should choose. Like this, right? Right? The larger triangle. Okay. So you can determine the theta there based on this angle, from this angle. So this length should be 2.16. Okay. And this length is 0.15. You will get theta 1. Okay. I give some idea. Maybe you should solve it later because we are running out of time. Okay. Okay. This is the idea. Okay. So get theta 1. And theta 2 should be here. This triangle. This one 0.2. And the other one is 0.15. Okay, you will get theta 2. So put the value of theta in the FBD. You can easier your works later on. Okay, theta 2. Okay. All right. We have 1 minute left. Okay. The last question from me. So once you have this FBD, this FBD is completed. Okay, it's already completed. So what is the first method to do analysis? What is the first method to do the analysis? And what is the first method to do analysis? Yes, equilibrium. Okay. Equilibrium. So we in 2D we have 3 lah. fx, fy, and moment. Okay, which one you want to start first? Fx, ay, or moment? Okay, moment. Which point? Which point? Which point you want to start? Yeah, of course, D lah. As I mentioned to you, you have to eliminate the the unknowns. Okay, and you have to select the unknowns where you have to select the point where the unknowns is larger, and the point that having the larger number of unknown is D. So you have to calculate moment about point D lah. Okay. Using the equilibrium system. From here, you will get straightforward T value. Okay. This is the idea. I give you an idea, then you have to solve it later. So next class, I will ask the answer. Okay. From the moment, you will get D, and from the Fx, okay, you will get dx, and from the Fy, you will get dy. That's it. Okay, so I give the idea. Please do it. Please do it before we discuss, before we reveal the answer in the next class. Okay. Yes, I will upload the lecture 7 later on. Okay, I think that's all for today because I have audit at 11 AM. So thank you so very much. See you next week. Next week kita ada kelas ke? I'm not sure. Okay, see you next class.
Holiday.
Holiday start when?
Next week, the whole week.
Start Sunday lah.
9 May.
Yes, from Sunday, 9 May to 13 May.
From Sunday, let me check my schedule. From Sunday 9 until 13.
Yes,
Sorry, until
13 May, Doctor.
yes, 13 May.
until 30 May. Oh, 30. 30.
1-3, Doctor.
138 until 13. Because next one. Okay, never mind. Okay. Alright. I think until 16 should be 16 because 16 is holiday as well. Okay. Alright, thank you so very much. See you after Raya lah. After Raya. Okay. Alright. Bye. Assalamualaikum.
Thank you, Doctor. Sorry, Doctor.